Here's example 2 with graphing a sinusoidal function with the phase shift. So remember, sinusoidal is just a fancy term for sine or cosine. So here's example 2, graph y equals 2 times the sine of the quantity 3x plus pi and then minus 1. And then also we want to find the domain in the range. So we're going to follow this same set of steps that we did for example 1. And also when we did example 1, we talked a lot about some of the details of these steps and how they relate to the same process when we don't have a phase shift. And we talked about similarities and differences. So we won't go through it all again, but if you're curious about those, check out the video for example 1. So anyway, we're just going to go ahead and go through this process here. So this video will be a little bit shorter than the other one. So first we find the period t. So remember, t for sines and cosines is always just 2 pi over the absolute value of omega. Okay? So before we move on, let's identify what's omega, what's a and b and phi and all that stuff. So now this is a sine function, so in general we have y equals a times the sine of omega x minus phi plus b, right? So what do we have though? We have y equals 2 times the sine of 3x plus pi minus 1. So in our specific case, y equals 2 times the sine of 3x plus pi minus 1. Okay. So right away we see that a is 2, omega is 3, and then b is negative 1, right? So let's go ahead and write those up here. A equals 2, omega is 3, and then b is negative 1. Okay, but we have to be careful about phi, right? It's tempting maybe to say phi is pi, but we got to be careful because these signs don't match up. So remember, it's omega x minus phi, but here we have 3x plus pi. So what we want to do, remember 3x plus pi, that's the same thing as 3x minus negative pi, right? So if you subtract a negative, you're really adding. So we want to split it up like that. So why do we split it up like that? Because then everything will match. So then we have 3x minus negative pi. Okay, so then what we have here is omega is 3. Let's zoom in a little bit on that. Here, omega is 3, x is x, minus sign with that minus sign, and then phi is everything that's left over. Okay, so phi is negative pi. Okay, so omega 3, x, x, minus sign, and then phi is what's left over, which is minus pi. So that's why phi is minus pi. It's actually similar to how b is negative 1. So it's blah, 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 plus b. So this is really like plus negative 1, right? So the plus sign matches with the plus sign, so then b is everything left over, which is the negative 1. Okay, so it's actually pretty much the same line of thinking. Just feels a little more natural maybe with that. But anyway, so phi is negative pi. Lots of Greek letters here. Okay, so let's get rid of all this then, and we'll continue with the problem. Zooming back out a little bit. So t is 2 pi over the absolute value of omega. Omega is 3, so the absolute value of 3 is just 3. 3 is already positive. So this is just 2 pi over 3. Okay, now that's it for step 1. That's great. Find the period t. We just did. It's 2 pi over 3. Which means every 2 pi over 3 units, the graph is going to start repeating. That's what that means. Okay, so remember we talked about period way back in a separate video. Now step 2, divide this crazy interval into 4 subintervals of equal length. We talked a lot about this interval, why it is what it is in in example 1. I mean, and, you know, we said we could use really any interval we want, but this is probably the best one to use because it simplifies step 3 quite a bit. Anyway. So this is the phase shift, right? Phi over omega, that's the phase shift. So we want to start at the phase shift, end at the phase shift plus the period. Okay, so we're going to start at the phase shift phi over omega, which is what? Well, phi is negative pi, omega is 3, so phi over omega is negative pi over 3. So this is negative pi over 3, okay? It's not terrible. Where do we end? So we start at phi over omega, we end at phi over omega plus t. So this is going to be phi over omega plus t. Okay. Phi over omega, we just found out that's negative pi over 3. Okay, that's our phase shift. And then plus t, well, we already know that t is 2 pi over 3. So that's 2 pi over 3. So this is phi over omega plus t, okay? And that simplifies to what? So that's really 2 pi over 3 minus pi over 3, which is just pi over 3. Okay, that's good. So now, for step 2, what we're going to do is divide this interval negative pi over 3 to pi over 3 into 4 subintervals of equal length, which will give us 5 x values. So again, just like in example 1, and just like the other videos with no phase shift, we don't really have to think of them as intervals. We just have to set up this little number line type thing here. So here, let's maybe use a different color for this. This is negative pi over 3. It's where we start. Okay, it's where we start. This here is positive pi over 3, where we end. So what we do is divide, so here's our interval here. Okay, we're going to divide it into 4 subintervals, but again, we don't have to think of it like that. All we have to do is divide it in half. Okay, and if we divide that in half, what number is exactly in the middle? So it's a little easier here. It's positive pi over 3, negative pi over 3, so this one's got to be 0, right? But in general, you can add these up and divide by 2. So pi over 3 plus negative pi over 3 is 0. 0 divided by 2 is 0. That's how we get that. Now we do the same thing with this part and this part. And then that'll be it for step 2. So divide this guy in half. What do we? So forget about this one, just divide this little interval in half, and then we end up with this thing here. What is that? Pi over 3 plus 0 is pi over 3. And then if we take pi over 3 and divide it by 2, that's really pi over 3 times the reciprocal of 2, which is a half. So pi over 3 times a half is pi over 6. Okay? So this is going to be pi over 6 right here. Okay, and then we do the exact same thing over here. Okay, and of course if this is pi over 6, this will be negative pi over 6. But if you're not comfortable with that, just do the exact same thing. Negative pi over 3 plus 0 is negative pi over 3. Negative pi over 3 divided by 2, well, negative pi over 3 over 2 is negative pi over 3 times a half is negative pi over 6. Okay? Okay, so that's it for step 2. Blah, blah, blah. This will make 5x values, so we got our 5x values here. Now we're going to take these x values and plug them into the function to get the corresponding y value. So find the y value at each of these x values. That's what we're going to do now. So again, what are we doing? Why are we doing that? Well, what we did here, first we found the period, then in step 2, we took an interval whose length is equal to the period. So in other words, we took one complete cycle on the graph, and on this cycle, we just found 5x values. Now we're going to take these 5x values on that cycle on the graph to get the corresponding y values, and then once we have those y values, we're going to have 5 points that make up one complete cycle, and then we're going to plot those points. Okay, that's what step 4 is, plot the points. So now what we're doing is we have 5x values covering one complete cycle of the graph, and now we're going to get the corresponding y values for that cycle. Okay, so let's erase this, maybe erase this too, but we'll write down again what it is. So this was positive pi over 3. Just want to make some room for ourselves over here. Set aside a bunch of space. Okay, so now, just like we always do with this type of problem, whether there's a phase shift or not, we're going to take each of these x values one at a time and toss them into this function and evaluate to get the y value. So first is x equals negative pi over 3. Okay, when x is negative pi over 3, what's going on? Let's maybe zoom in a tiny bit. When x is negative pi over 3, y equals 2 times the sine of 3 times negative pi over 3 plus pi minus 1. Right? 3 times negative pi over 3, so that's relatively simple, but let's just be thorough with the details here. 3 times negative pi over 3, the 3's cancel, we end up with negative pi plus pi, which is 0. Okay? So that's great, so what we have is really 2 times the sine of 0 minus 1. Sine of 0 is 0, so that's 2 times 0 minus 1, which is negative 1. Okay, so really this gives us, let's erase this, and this gives us the point, when x is negative pi over 3, corresponding y coordinate is negative 1. Okay, so that's what we have there, negative pi over 3, comma, negative 1. Okay? Okay. Now what about the next, so that's the first x value. For the second x value, we have negative pi over 6. So when x is negative pi over 6, what's going on? then in that case we have y equals 2 times the sine of 3 times negative pi over 6 and then plus pi. We still have a minus 1. Okay, so let's simplify this separately. So 3 times negative pi over 6 plus pi. Well, 3 goes into 6 twice, so that's really negative pi over 2 plus pi. If we want a common denominator, multiply this guy by 2 over 2. So this is really, let's come down here, negative pi over 2 plus 2 pi over 2. Okay, so that's really 2 pi over 2 minus pi over 2, which is just pi over 2. So that's just pi over 2. Okay, so that's great. That simplifies pretty nicely. So this is 2 times the sine of pi over 2 minus 1. Okay, so again, 3 times negative pi over 6 plus pi, all this down here shows that that simplifies to pi over 2. So minus 1. So sine of pi over 2 is 1, so this is 2 times 1 minus 1. 2 times 1 is 2, 2 minus 1 is 1. So this corresponds to the point negative pi over 6, comma 1, because when x is negative pi over 6, y is positive 1. Okay? So let's write down the coordinates of that point. So first we'll erase this. And then this corresponds to the point negative pi over 6, comma 1. Okay, so I want to write that up here just to make sure we have enough room. Okay, what's next? 0, x equals 0. That's a nice value. When x is 0, what's happening? We get y equals 2 times the sine of 3x plus pi, so 3 times 0 plus pi, and then minus 1. 3 times 0 is 0, 0 plus pi is pi, so this is 2 times the sine of pi, and then we still have a minus 1 there. Sine of pi is 0, so that's 2 times 0 minus 1, so that's 0 minus 1, which is negative 1. Okay, so what we just found out is that when x is 0, y is negative 1. So that gives us the point 0, comma, negative 1. Okay. Okay, next, pi over 6. So we see either this, like we mentioned in the other example, this step is probably the most tedious because we're just kind of doing the same thing 5 times in a row, just with different values. And it gets a little repetitive, but it's good to get practice doing this kind of thing because it helps with simplifying expressions and evaluating trig functions, things like that. It's good to get that kind of practice. Anyway, so when x is pi over 6, that's our next one. We have y equals 2 times the sine of 3x plus pi, so 3 times pi over 6 plus pi minus 1. Okay. So 3 pi over 6 plus pi, so 3 times pi over 6, that's 3 pi over 6, and then plus pi. So 3 pi over 6 simplifies to pi over 2, because 3 goes into 6 twice. So that's pi over 2, and then plus pi is still there. Common denominator again, so multiply by 2 over 2. So then this is pi over 2 plus 2 pi over 2. So 1 pi over 2 plus 2 pi over 2 is 3 pi over 2. Okay. So 3 pi over 6 plus pi simplifies to 3 pi over 2. So let's erase this. So then this is going to be 2 times the sine of 3 pi over 2 minus 1. Okay. And then sine of 3 pi over 2, that's negative 1. So this is 2 times negative 1 minus 1. So 2 times negative 1 is negative 2. Negative 2 minus 1 is negative 3. Okay. So this blue is kind of running out. Maybe I'll switch to green, which also isn't doing too good. So then this corresponds to the points pi over 6, comma, negative 3. Because when x is pi over 6, y is negative 3. Okay, so pi over 6, comma, negative 3. Okay. All right, and one more to go. So maybe the blue will hold out. So pi over 3 is our last one to look at. All right, when x is pi over 3, what's happening? We have y equals 2 times the sine of 3 times pi over 3 plus pi, and then minus 1. Okay. Well, 3 times pi over 3, the 3's cancel, and we're just left with pi plus pi, which is 2 pi. So that's 2 times the sine of 2 pi minus 1. Well, the sine of 2 pi is 0, so this is really 2 times 0 minus 1. 2 times 0 is 0, 0 minus 1 is negative 1. So we'll put that down here. Okay, so in other words, when x is pi over 3, y equals blah 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 equals negative 1. So this is pi over 3, pi over 3 comma negative 1. So that's the point we get from there. So that's pi over 3, completely out of room here, comma negative 1. Okay, so those are our 5 points. We got our 5 corresponding y values, so that gives us our 5 points. And now step 4, plot the points that we get and smoothly connect in that curvy fashion that sine and cosine have, and then extend the graph as needed. So extend the graph as needed, what does that mean? Well, we're just graphing one complete cycle, so we might want to graph more, just in case we want to be a little more thorough. Anyway, let's go to our graph paper here. So if you want to follow along with graph paper, and if you don't have any, check the video description. There will be a link in there. Go ahead and click that link, open up some graph paper, and you'll be good to go. Okay, so now we want to look, what kind of values do we have? Negative pi over 3 comma negative 1, negative pi over 6 comma 1, 0 comma negative 1, pi over 6 comma negative 3, pi over 3 comma negative 1. So our scales are going to have to be a little bit different, because we see for the x values we have pi's flying around all over the place, but for the y values, negative 1, 1, negative 1, negative 3, negative 1, they're not too bad. Okay. So I think what I want to do is, alright, let's zoom in a little bit here. Set up an x-axis here. I'm going to make it go all the way across for no particular reason, I guess. And then put a y-axis somewhere over here. Okay. Okay, so x-axis, y-axis. All right, now let's look at our x values here. Negative pi over 3, negative pi over 6, 0, pi over 6, pi over 3. So I think what I want to do is make every 2 grid units equal to pi over 6. So here's one grid unit, here's another one. I'm going to make that pi over 6. Okay. Here's another 2 more grid units. So that's going to be 2 pi over 6, but 2 pi over 6 is pi over 3, right? So 2 pi over 6 equals pi over 3. So that's going to be pi over 3. Okay, so remember, this is pi over 6, so this is going to be 2 pi over 6. Oops, 2 pi over 6, which is pi over 3. Okay. Now, this one's going to be 3 pi over 6, but 3 pi over 6 is pi over 2. Okay. This is pi over 2. This next one's going to be 4 pi over 6, but 4 pi over 6, 4 pi over 6 simplifies to 2 pi over 3, right? Pull out a common factor of 2 and we get that. So this guy is going to be 2 pi over 3. Okay. 5 pi over 6 can't be simplified. This next one is 6 pi over 6, which is just pi. Okay. We'll stop there for now. Now let's go back the other way. Negative pi over 6, negative pi over 3, negative pi over 2, negative 2 pi over 3, negative 5 pi over 6, and negative pi. One of these labels might actually get in the way a little bit of the graph, but that's okay. Oops, probably should have zoomed out a bit. Okay, so now what about the y scale? So the y values are negative 1, 1, negative 1, negative 3, and negative 1. So let's make the y scale be every 2 units, every 2 grid units is 1 unit. So 1, 2, 3, 4. This will be negative 1, negative 2, negative 3, negative 4, negative 5, and that's good. Okay, now let's go ahead and plot some points. Negative pi over 3, comma, negative 1. So here's negative pi over 3, comma, negative 1. Okay. Negative pi over 6 comma positive 1. Okay, so again, if you use a different scale, your graph will probably look quite a bit different. 0 comma negative 1, that's next. It's right here. 0 comma negative 1. What's next? Pi over 6 comma negative 3. That's way down here. Then pi over 3 comma negative 1. Pi over 3 comma negative 1, that's right about here. Okay. And this battery is almost dead, so let's plug this into the charger. Pardon me for just a sec. Okay. Getting back to this. So these are the 5 points here that we found in step 3. So now in step 4 we're going to plot these and smoothly connect. So now we just want to smoothly connect these guys. So this here was negative pi over 3 comma negative 1. This is negative pi over 6 comma 1. This one here is 0 comma negative 1. Here is pi over 6 comma negative 3. And then here is pi over 3 comma negative 1. Okay. Okay, so now we smoothly connect kind of a sine style. Oh, that is terrible. Ugh, all right. All right, and again, if you have a different scale, your graph might look quite a bit different. It's going to have that same shape, of course, but it might seem a little stretched or shrunk a little bit. And if you toss this into a calculator, chances are your calculator has a different scale than what I have set up here. But anyway, just keep that in mind, that it'll look a little bit different with a different scale. But anyway, so step 4, plot the points and smoothly connect, extend the graph as needed. So let's extend this a little bit using the period here. So here's pi over 3 comma negative 1. So we know that, what's the period again? The period is 2 pi over 3. T is 2 pi over 3. So what that means is if we go 2 pi over 3 units in to the right or to the left, we're going to have that same shape. Okay, so here's one complete cycle. If we go 2 pi over 3 units, we're going to have that same cycle again. Another 2 pi over 3 units, same cycle again. Same thing if we go to the left. 2 pi over 3 units here, we're going to have that same cycle, same shape. 2 pi over 3 units to the left, same shape again. Okay, so let's go ahead and do that. Let's extend to the right, I guess. Why not? Okay. So pi over 3, if we start at pi over 3 and if we go 2 pi over 3 units to the right, again, why is that? Because the period is 2 pi over 3. Okay, so if we go to the right by the length of one period, 2 pi over 3, where are we going to be? Well, pi over 3 plus 2 pi over 3, okay, so pi over 3 plus 2 pi over 3 is 3 pi over 3, which simplifies to just pi. Okay, so we're going to be at pi comma negative 1. Okay, pi comma negative 1, that's good. So this is pi comma negative 1. Now, how about here, pi over 6 comma negative 3. So if we take pi over 6 and add 2 pi over 3 to it, you know, we can just kind of eyeball the graph and see, oh, that's going to put us here at 5 pi over 6. But if you want to be thorough about it and show work, you could say, okay, pi over 6 plus 2 pi over 3. Again, add 2 pi over 3 because we're going to move to the right, so we add to increase the x value and then get a common denominator. So multiply by 2 over 2. So that's pi over 6 plus 4 pi over 6, which is 5 pi over 6. Okay, so that's how we get here. And then we have the same y value, 5 pi over 6 comma negative 3. Because again, it's just the periodic properties of sines and cosines. If you go to the right or to the left, a length equal to the period, or really any multiple of that, so I can go 2 pi over 3, 4 pi over 3, 6 pi over 3, 8 pi over 3, really anything like that, then we're going to have the same y value. Okay, so that's what that tells us. What's next? So 0, if I start at 0, x equals 0, and go to the right 2 pi over 3 units, I'll be at 2 pi over 3. So that one's a little bit easier. So this is going to be 2 pi over 3 comma negative 1. And then here, negative pi over 6, if I start at negative pi over 6 and go to the right 2 pi over 3, I'll be at pi over 2. And again, we have the same y value. So we'll just show the details just because we want to be thorough and show all the details. So negative pi over 6 plus 2 pi over 3. Okay. So multiply 2 pi over 3 by 2 over 2, okay, so that we can get a common denominator. So that's going to be negative pi over 6 plus 4 pi over 6. So it's 4 pi over 6 minus pi over 6, which is 3 pi over 6, which simplifies to pi over 2. Okay. And then that's the same y coordinate because we went over the length of one period, and we get pi over 2 comma 1. Okay, same y coordinate as this point here. Okay, so then we just smoothly connect sine graph style. Okay, not terrible, I guess. And then let's extend a little bit and put an arrow on it, and then we'll extend this one down a little bit, put an arrow on it. Youch. Okay. That's pretty bad over there, but anyway, so this is y equals 2 times the sine of 3x plus pi, and then minus 1. All right, so that's it for the graph. Now remember, we also had to find the domain and range, right? So we'll zoom back out a little bit. So remember, in the original problem, we were asked to find the domain and the range. So the domain and range really won't be that bad, especially the domain. So the domain, remember, what's the domain in general? It's the set of all the x values where the function is defined. So what is our function? It's y equals 2 times the sine of 3x plus pi minus 1. Is there any number of x that we're not allowed to use there? No, okay, we can multiply anything we want by 3, then we can add pi if we want. We can take the sine of any number we want, no restrictions there. And of course we can multiply that by 2, then we can subtract 1. Okay? And also if you look at the graph, you'll see these arrows indicate that the graph just keeps going on forever and ever and ever in both directions. So this is going to touch every x value. Okay, so the domain is all real numbers. Because you can take any x value that you want and stick it into this function. Okay? Remember, the domain is the set of all the valid or possible x values that you can use. Okay, what about the range? Let me zoom in a little bit here. The range is the set of all the valid y values, or basically the set of all the output values that the function actually gets. So what we do for the range is we look at the graph and say, or we ask ourselves 3 things. What's the smallest y value? What's the largest y value that we hit? And do we get everything in between? Okay, so first of all, what's the smallest y value we hit? It's -3. Okay, we do hit it at this x value, infinitely many more over here and over here. Okay, but -3 is the smallest one. So -3 with a square bracket because -3 is actually obtained by the graph. So we have a square bracket. Okay, so that's interval notation details from a previous course, really. There are some separate videos on that if you need a refresher. Anyway, what's the largest y value we get? It's +1. It happens here and here. Right over here somewhere also, in infinitely many places this way and that way, over this way. So, -3 comma 1, put a square bracket on the 1, because we actually do get that value. And then remember the third question was, do we get everything in between? Yeah, we see that for every y value in between, we do actually hit them at some point, right? So like this y value right here, whatever it is, we do hit it at this point here. And then this y value here, whatever it may be, we do hit it right here. This y value right here, we hit it over here and over here. Okay. So the point is, for every y value in between -3 and 1, there is some corresponding x on the graph, or there is some corresponding x value such that if you plug in that x, you're going to get that y back. Okay. So since the answer is yes, we get everything in between, that means all we have to do is just, this is our answer for the range. So if the answer were no, we don't get everything in between, we'd have to do something more complicated with unions. But luckily for sines and cosines, we don't have to worry about that kind of thing, especially because we're not doing anything too crazy. We're not squaring anything, no square roots, nothing like that. That's good. Okay, so that's our domain and range. And that's really it for example 2. So we see that's pretty much almost identical to example 1, just we have a sine instead of a cosine, so that changes the evaluations in step 3. But really the steps are otherwise exactly the same, right? Okay, so that's it for example 2 for graphing a sine or cosine function with a phase shift.